Okay, well, welcome. So just getting started, I just wanted, and if you can't hear, please let me know and I can use the mic, otherwise I'll just try to project. I'll just start with my background. I've been in research for a little over 10 years. I initially started at Oregon Health and Science University, or OHSU, looking at agricultural farmers' exposure to pesticides. And then I moved over to the National Institutes of Health, where I was at the National Heart, Lung, and Blood Institute in the Division of Lung Disease, doing some epidemiological work, looking at respiratory distress syndrome. And then I moved to what was then the National Center for Complementary and Alternative Medicine, but now is NCCIH. And I was in the endocrine section looking at prostatic stroma and lycopene, as well as Ayurvedic compounds in induction of phase 2 detoxification. I then went back to Oregon Health and Science University, or OHSU, and the VA, and was in the Department of Neuroimmunology, doing multiple sclerosis work, as well as in the Department of Pediatrics, looking at CAM use in peds. And now more recently I've been working with health research reporting guidelines, the case report guidelines or CARE guidelines, as well as scientific writing in health and medicine. And then here at NUNM, I developed a case report data collection tool to increase reporting from the point of care. So just briefly, a quick overlay. And then I also teach yoga. I'm a nutritionist and just have been really interested in complementary and integrative health. So I'm going to be talking about Helene Langevin. She was a featured speaker at ICIMH, the International Congress on Integrative Medicine and Health. And this Congress or meeting is hosted in the United States every other year, and then the alternate year is international. And she is currently at Harvard as a professor, and then also the director of the Osher, the Osher Center at Harvard at the Brigham and Women's Hospital. And she's done a lot of work in acupuncture as well as connective tissue or the interstitium. So just briefly starting out with the background. Historically, organ systems were mapped out in the 19th century, and we tended to just still use that model of how we've segregated the organ systems. And this, how we mapped it out in the early 19th century, still largely dictates on how we view anatomy and physiology. So when we look at the immune system or lymphatic system, as well as the musculoskeletal, we tend to keep them nice and separate instead of well integrated. And if we talk about the interstitium or connective tissue or the fluid in between compartments, it tends to just be this kind of like bland area. And then the same thing here where it's kind of like a side note to these other structures. So this has changed with different imaging that we have available to us, including confocal microscopy. Here is an astrocyte, and I believe these are fibroblasts. No, excuse me, these are microfilaments. So just with different imaging techniques, we can more clearly identify structures, especially in connective tissue. So here is some nice imaging here, looking at musculoskeletal fibers and connective tissue, and just seeing the continuum of how those structures are interconnected up through the chain of the body, and essentially how it's a tug of war. So when you are moving your muscles, how that just really involves all the fascia and moves things around. So when she started, when Helene Langevin started her work in more of the connective tissue area, so some of her overarching research questions were, can mechanical forces influence immune processes and cancer growth trajectory? So with the mechanical forces our body undergo, can we impact how inflammation takes place, and as well as cancer growth? And then what is the role of immune cell movement into the interstitium? So to start out, so that was the kind of the overarching direction of where she directed her work. So one of her initial studies is what are the effects of stretching and chronic inflammation. So she started out with a rat model as well as mice, and they, you can see here, they took the mouse or rat by the tail, and then the little front feet would reach down to like a little bar, and they actively, so in the first study they were focusing on the thoracolumbar fascia, so along the back area here, really connecting the shoulders to the hips. And so in this initial study she looked at stretching in rat model twice a day for 10 minutes for 12 days versus no stretching. And they use a carrageenan-induced inflammation model, so injecting carrageenan into the back region of the, well, this is a rat in this study. And so with the result, so their results showed that with stretched animals, they had lower pain sensitivity, reduced macrophage expression, and also restored strike length, which is pretty profound. With the 10 minutes of stretching twice a day for 12 days. So here is how showing the injection procedure, and yeah. And so the active, like, so this is a stretch mouse, and then they just essentially handled the mouse for the same amount of time for the no stretch group. So we're a little bit covered here, but study 2, comparison of active versus passive stretching and with anesthesia for 10 minutes every day for 2 weeks. So the study groups were anesthesia, no movement, passive stretching with anesthesia. So because the mice were under anesthesia, they were just, laid there, and they used this little device to I think it was like a 17-degree angle to stretch the body. And then they have the active stretch without anesthesia. So the results for passive and active stretching reduce inflammatory lesion thickness versus anesthesia only. So you can see here there is a statistically significant difference between anesthesia only and passive stretching, as well as anesthesia only and active stretching. There was no statistically significant difference between the passive and active groups. And they did ultrasound, and they saw clearly that there was improved resolution in the stretching groups. Okay, so moving into some background. So with normal wound healing versus persistent and chronic inflammation. With the chronic inflammation, we tend to see connective tissue be kind of thicker and denser and more fibrous. So I don't know how many of you are familiar with Charles Sirhan's work, but he's been a pioneer in identifying specialized per-resolving mediators, or SPMs. And a good portion of those are derived from omega-3 fatty acids. So here specifically looking at protectins, merisins from DHA, and then from EPA we have resolvins. SPMs are actually released at the beginning of inflammation, and then within a healthy kind of resolution time frame, help to terminate inflammation in 2 to 4 days. And if unsuccessful, if they're not in the area, it can lead to a prolonged inflammatory state and lead to valve resolution and fibrosis. So her subsequent research question was, is stretching activating SPM pathways? So study 3, is the effect of injecting resolving mediators similar to the result of stretching? With injection of SPMs, we wanted to evaluate the local effect in extracted tissue, placed in a bath and stretch, okay, the part 1 to this study was looking at the local effect. So they extracted the tissue and they placed it in a bath, stretched it, and then they measured the resolvent concentration. Results were that there were an increase in resolvents in the stretched tissue. Part 2 was adding FMLP, which is a potent polymorphonuclear leukocyte, or PMN, chemotactic factor and macrophage activator. So it brings inflammation and brings inflammatory cells to the area. And so neutrophils are attracted into that tissue area. And the results were there was less neutrophil migration in the stretched tissue. So one could suggest that stretching helps to activate a per-resolving response, pushing and balance of resolution. Okay, so going more into the background, fibroblasts make resolvents. So the resolvents are there holding onto the matrix, controlling the tissue. And then here's a nice image of fibroblasts. And so if we go into the oncology realm, a lot of the focus has been on the cancer cells themselves and getting rid of the cancer cells. And this has been shifting in the last 20 to 30 years. We're now interested in the surrounding stroma. What is the environment that the cancer cells are growing in? So stroma plays a big role in whether cancer cells will grow, and I can attest to this working in the prostate cancer model. So in chronic inflammation, connective tissue will be fibrotic. It can promote a desmoplastic response and then ultimately end in a poor prognosis, so supporting cancer's growth. So essentially, cancer cells like this stiffer connective tissue. So therefore, stiffer connective tissue is an important predictor of cancer cell growth. So next research question. What is the role of stretching in cancer? So they looked at a breast cancer model in mice and evaluated stretching. And they found that there was a 50% lower cancer growth in the stretch mice. And and then this is interesting, higher TNF alpha and interferon gamma levels, so supporting some more greater presence of kind of inflammatory processes, an increase in gene expression of general inflammatory responses in stretch mice. So what does that mean? So if we're looking at interferon gamma in cancer, so in cancer we'll have cytotoxic T cells, which are the main defense against pathogens, as well as having a role in cancer. T cells release interleukin-2 and they promote clonal expansion, interferon gamma, TNF alpha, perforin, and granzymes to kill pathogens in cancer cells. So they have a positive, helpful role. So with that said, we want to keep that controlled. We want to have checkpoints in place. And if they go out of control, it can lead to chronic inflammation. So we want to have immune checkpoints for that T cell activation. And then also, if the immune system is exhausted from overuse or for whatever reason, this cytotoxic cytokine release, so these cytokines that I mentioned lessen, so they're not as present, which leads to less cytotoxic activity, which could promote cancer cell growth. So next research question is, does stretching wake up T cells in chronic inflammation? So if the immune system is exhausted, how can we get these cytotoxic T cells ready to go and fight? So they looked at stretching again, and results in stretched animals, they saw a decreased PD-1, which is a major immune point inhibitor, because we want to promote as opposed to inhibit. And then an increase in interleukin-2, so an increase in interleukin-2, and then as well as that decrease in PD-1 allowed for an improved immune response in the stretch group. Okay, so I'm just going to quickly keep moving forward. So this is back to Sirhan's work and looking at the SPMs. So cytotoxic activity causes subsequent apoptosis and cellular debris. So with that cytotoxic T cell activity, we want to then move into cleaning up. So macrophages respond, release cytokines, and then we want the resolvins there to help with cleanup. So next research question, can stretching induce cytotoxic activity in a cancer model and support the production of resolvins? So their results were stretching increased cytotoxic activity and resolving cleanup. So they had the inflammatory response, they targeted what they needed to target, and then they were able to clean up. Future research directions. So they've used mice, they've used rats, and they've used a porcine model or pigs. So now it's time to move into humans. So we need to investigate stretching in cancer patients as well as patients that face chronic inflammatory conditions. Dilemmas are that there are some past studies that suggest breast massage may promote mechanical transport of cancer cells to lymph nodes, so therefore encouraging metastasis. So we can say, yay, this is exciting, we can reduce the trajectory of cancer growth, etc. However, we need to consider about metastasis and stretching versus massage versus other kind of movement in the connective tissue. So looking at research questions, what is the role of stretching in human cancer patients? Will we observe cancer growth reduction? What is the minimal amount of stretching required? Is 3 to 5 minutes sufficient? And what is the appropriate strain and stretch of that tissue? And how much variability is there between individuals? So applications for clinical practice. Can we think about prevention? Can we, so when we're talking about stretching, so recent studies have shown that gentle daily stretching for 10 minutes can reduce local connective tissue inflammation and fibrosis. So from a naturopathic perspective, a Chinese medicine perspective, etc., just really encouraging everyone to be stretching. And then what are the implications for practices like yoga, tai chi, massage, physical therapy? So here are slashing the references. There is a lot more. She's done a lot of work in this area. And I encourage you to, they are intending to move to the human model, so if you're interested, I encourage you to follow her work. She's also done a lot, like I said, in acupuncture. And thank you. Any questions? Yeah.
Does the stretching, like with regards to cancer, is it specific to the site? You mentioned breast cancer, so were you suggesting that we stretch the breast cancer tissue? Is that what
So they focus a lot on thoracolumbar because that, in animal models especially, that was kind of a good reference point. I guess one would suggest that you would be more localized to that area, but they don't know. Yeah. And this is not my area of expertise. I, just went to her presentation, so I'm just giving you a synopsis of that presentation. I haven't looked to see at all of the areas in the body that they have investigated, but that was reoccurringly the area that she had drawn focus to.
And so did you say that passive and active stretching were the same result?
Yeah, so the passive was under anesthesia, so that they both had positive effects, yes, they were not statistically significant between the two groups, but one would have some concern over time using anesthesia. But yeah, passive movement or having someone else like Thai massage or something like that where it's stretching and someone else is doing the stretching for you, that would be showing benefit. Perhaps, if we were to translate to human models, which I can't definitively say, but one would suggest that. Any other questions? Yeah.
I noticed there was an image from Tom Myers' work, the anatomy trains. Is that spoken about in the talk, or are you familiar with that?
Tom Myers,
He's the one he's in the Rolfing community, so just the idea that the connective tissue being, these long trains, rather than just separating them. And I was just interested if she mentioned that, or I guess probably.
Yeah, that is a suggestion, is that everything is connected, and when we look at, I guess I didn't elaborate on it too much, but the tug of war. So if you are contracting your biceps, what are the implications for the surrounding interstitium? What are the implications for the surrounding muscle tissue? It is all connected.
Right, and in that sense, if you're doing generalized stretching, it can improve other parts of your body that aren't in that localized area.
Yeah, and then that would go back to Moses, your comment about the breast tissue. Maybe you could do stretching in other parts of the body and it would positively affect the breast tissue, and that's what I would venture to hypothesize. Yeah, but we don't know, but maybe we do know, right? All right, is that it? Thank you.